everybody. Thanks for dialing in today. And we're going to be recording this. So for you guys that are watching it, hello to you too, are watching it online. But we're going to talk a little bit about Onshape and SOLIDWORKS and kind of how you would work with Onshape if you were a SOLIDWORKS person. I'm just going to do a couple PowerPoint slides at the beginning, and then we'll work with the software as well. But I wanted to start off with a history lesson. So first of all, in the middle column here, we have Onshape, when it was founded, 2015, SOLIDWORKS, 1995, so 20 years difference. Hauntingly similar, same people, started both companies. So they are very similar. Onshape is more of an MCAD, mechanical CAD package, sort of like what SOLIDWORKS was maybe 20 years ago. But, as over the years, they've expanded their capabilities. So, we got manufacturing, a bunch of other things in there as well. Software delivery. Software as a service for Onshape, it's in the cloud. SOLIDWORKS, like everybody else, traditional download, install on your computer type thing. Learning curve, is it easy? Is it hard? It's up to you, but they're all pretty much the same. If you know Onshape, you can learn SOLIDWORKS. If you know SOLIDWORKS, you can learn Onshape. Security, because it's in the cloud, it's highly encrypted. All the security is there in the cloud, and basically, for your SOLIDWORKS seats, it's whatever you're using on your computer to do security, or in your company, firewalls, things like that. Not a lot of modeling features compared to SOLIDWORKS because it's newer, but the features are also a little bit different. So you can do a lot of things with just one feature. Also, updates. The updates with Onshape are like every 3 weeks, right? Every 3 weeks. New stuff is added. Way that SOLIDWORKS and everybody else works, you send out an update, you can download it or not download it. Then you can start to get mismatched between you and your customers, your vendors. It doesn't happen with Onshape, right? When they update Onshape like that every 3 weeks, everybody is on the same version all the time. Operating systems, Windows, Mac, OS, just about anything. It's BYOD, bring your own device. And, obviously SOLIDWORKS is on Windows. So there's this comparison here, and we can talk about administration and things like this. The check marks on one side and not the other. We're not bashing SOLIDWORKS. You can put anybody's CAD system here. Put in NX, put in Creo, put in Inventor, whatever you want. They're all going to have pretty much the same results that we're going to look at today. I'm not going to go through each one of these. If you are watching this on a video, you can always stop it and read these things. But here's what I mentioned earlier. New features, fixes every 3 weeks. But we'll kind of move on and look in some other support and education. Onshape's all the education obviously is in the cloud, which makes that unique, but everything else is in par with your typical CAD system. Here we have some part modeling, sketching, creating 3D solids and parametric surfacing, and all of that is there. One of the things, advanced mold design. So, as SOLIDWORKS grew over the years, they got more and more capabilities. So molds, doing weldments, piping, cabling, things like that are part of SOLIDWORKS, whereas with Onshape, a lot of times we would go maybe to a third-party package to do that. If we look at assembly modeling, again, fairly similar. They use this word mates, and we'll talk about this in a little bit. They're a little bit different in the two systems, but the ideas are fairly similar. Some of the things with Onshape is we can do kind of what we call controlled in-text editing. And we're going to see this little check mark also for drawing. So if a part updates, since Onshape it's in the cloud and multiple people can be working on the same part or the same assembly or the same drawing at the same time, if something does change, it will automatically update. So if I'm working on a part and somebody's sitting working with it in the assembly, the second that I finish making a change to that part, there's a little indicator next to that part in the assembly saying, this part has been updated. It won't automatically update it. That's what Onshape does. It will tell you if something has changed, and it will leave it up to you whether you want to incorporate that change or not. So that's what this meant by kind of controlled in-text editing. And then collision detection, SOLIDWORKS has that. So let's look at the next page here. Again, pretty much a wash with CAD import and export. You read in files. Onshape does not convert features of anybody's CAD system. They'll bring that in. You just say basically import SOLIDWORKS, import native NX, import native Creo, and it opens them up, or Inventor, or anybody else. Onshape doesn't have files. It doesn't have a particular extension because it doesn't make files. You can ask it to write out a file. You could say write out a SOLIDWORKS file, write out a Rhino file, write out STEP or IGES, but in and of itself, it doesn't have its own files because it isn't a file-based system, right? It's really a database with a CAD system wrapped around it. The reason it's a database, multiple people can access a database at the same time. That's why Onshape can have multiple users working on the same part at the same time. And also with a database, you have data management. So speaking of data management, it's built in with Onshape. So being able to manage releases, doing different versions, workflow, where used, all that type of stuff is already part of Onshape. Right? So we don't really distinguish, you buy a CAD system and then later on you got so many files, oh, I got to go out and buy a data management system. No, it's just all in one product. And then there's also certainly the capability of sharing. Onshape shares things a little bit differently than with other systems. When we share something, you know, like you might use eDrawings, and people can get that and look at the files. Onshape, you can send them a link, just cut and paste, because right, it's in the web. You just go up here and grab the link, send it to somebody. They can click on it. They can see the model, see the drawing right away. They don't need Onshape. They don't need to download anything. It doesn't cost you any money. It doesn't cost them any money. And it's just kind of the way that the viewer works there. So we can, you know, measure and explode and section cut and do all that kind of stuff. There also is, if you're using it on your phone, there also is a free app to download. So if you want to use Onshape on your phone, or your vendor does, they can call things up and then you can spin it around and do all that kind of stuff on your phone if you wanted to do that. There's also the ability to do live chats. So we realize that people aren't always under the same roof or sitting next to each other. And you still might want to communicate, certainly if you're also working on the same part together or assembly together. So there's live chat. They can go back and forth and send images and things like that. There's also markup capabilities. So if this is out on the shop floor, manufacturing finds an issue, they can mark it up. And it right away just goes right back to engineering and they can see the markup and, you know, make the changes. So a lot of cool capabilities just kind of built into the way that Onshape works. And also that concept of workflows, we can assign tasks to people. I need you to develop this particular part. And it shows up on their screen as, you know, this is on your tasks panel. And as soon as you finish it, you say, I'm done, and then it's removed from your panel. So that's kind of a data management-ish type thing to assign tasks and workflows to people. And then analysis and rendering. Onshape does kind of what SOLIDWORKS did back in the day, right? Work with a lot of different partners to allow us to do structural analysis or rendering, kinematics, those kind of things. The thing is that a lot of our partners that we work with are cloud-based. So to access their app, you just click a button in Onshape and you're right into the app, right? Real-time working. So it's actually pretty cool the way that that all works. So I always ask myself, why do I need Onshape? This is a big one for the SOLIDWORKS people. Well, for anybody who uses CAD. No lost work. So software crashes, everybody knows that. If you think about your career and how long you spent on CAD and how much time you've lost and work you've lost due to crashes, if you ever added it up, it's a lot. And it's not to say that, you know, CAD systems are terrible, but they're software and they crash. And if you're not saving all the time, you lose work and then you have to redo it. Onshape, you never, ever lose work. I'm not going to say it doesn't crash, but you can't tell. If it ever does, you'll never tell that it crashes. So all it does is, you know, it's in the web or in the cloud on Amazon Web Services. And if Onshape, let's say if it were to crash or something bad happened to that server, it just rolls over to another server that's running Onshape. You never even notice. It's like you're driving down the street and you get a flat tire. The car automatically swaps out and puts in a new tire for you. You never notice it. You just keep driving. You don't have to pull over, pull out the jack, take the car off, or take the tire off, you know, do all that stuff. It just automatically, and it saves absolutely everything you do. So you never do lose your work. Easy to collaborate. Obviously, it's in the cloud. So and if you have an internet device, you can collaborate on Onshape. IT protection, because when we do give people access to look at Onshape or to work with Onshape, we control exactly what they can do. Can you make a copy of it? Can you delete it? Can you send it to somebody else? We control all of that. There's little check marks. How much authority or how much rights does that person have? And as soon as you give us a quote on this, here's our drawing. All you have to do is, after you get the quote, you hit a little check mark next to it. It's no longer shared with them. They no longer have access to it. You don't have to worry about your proprietary information wandering off somewhere. You send somebody a PDF drawing, who knows where it goes after you email it. No IT overhead. And that just kind of makes sense, right? Everything is done in the cloud. All you do is just log onto the internet through a browser, and you're in Onshape, right? PDM not required. I mentioned that before because Onshape does all the PDM stuff for you. So what do I do if I have a lot of SOLIDWORKS data? We've had this stuff for 20 years, and we've got thousands or hundreds of thousands of files. I don't want to use Onshape. It's too hard to bring all that stuff over. So there's a company we work with called Cassini PLM. And what they will do as a service is take things out of your EPDM system, out of your SOLIDWORKS system, and bring it into Onshape as a service. And you can go to their website, as you see here, and they have movies showing how that works. Here is a link to Onshape's movie showing going into SOLIDWORKS database, or data management system, I should say, grabbing the information and making it available in Onshape. So very easy to do that migration. If you need to do that, you won't lose work. The things, when they do come across, right, it brings across solids as a solid feature, a single feature. Like I said earlier, it doesn't translate feature for feature, but there are tools in Onshape to do non-parametric editing. It does feature recognition, recognize pockets or holes or bosses, or things like that. So some nice to haves, and this is more generic, not directly geared towards SOLIDWORKS or anybody else in that matter, but just things that I think are kind of cool. When you're working with Onshape, measure is always on. If I pick on anything, it's going to tell me how long it is or what its surface area is. If I pick on two things, it'll tell me how far apart they are or at what angles they are to one another. So it's always on. It's not a menu click or anything like that. We're going to look at this, but assembling parts, you usually only need one mate. Typically you say, well, I got to constrain all the degrees of freedom, and I got to do 3 different mates, or align these surfaces, or align this hole. It's a little, way easier in Onshape. We'll see that. Branching is really unique. So you think about it, if you're designing different ideas, you'll do a save as. And then somebody will start working on that. And then they might do another save as and generate another idea. And pretty soon you got all these save as files all over the place. And if they're in your PDM system, you got all these files. And if you never end up using them, they're just taking up room and they're just basically junk. But in Onshape, we do this thing called branching. So we have a single feature tree, sort of like a history tree. And we can branch off of that at any point and develop new ideas. And if we like those ideas, we can merge them back into the main tree. I'll show you an example of that instead of talking about it. It's a multi-body modeler. You're probably familiar with that if you're a Onshape person. So that means you can have a master sketch creating multiple parts. If you have information in a bill of material, you can type it into the BOM and it pushes it into the part. So there's that relationship. Configurations, we can control configurations by several different tables. I'll show you an example of that. And then finally, we can visually compare histories of a part, see how it's evolved over time, or compare 2 different parts, things like that. You always have access to the history. Everything that you've ever done is always saved. It's preserved, actually forever. So you can always go back to any point and get that information. So that's a little bit about my PowerPoint slide. This is Onshape. When you log in, this is the homepage. These are things that I've worked on recently. These are files, or folders, I guess I should say, that either people have given me access to or that I've created myself. One thing I want to touch on a little bit is we have preferences that we set up when we start up Onshape. So what kind of units do you want to work in? You can always change them later, but by default, what do you want your units to be, and things like that. We also realize that people that are using Onshape come from other CAD systems. So one of the things that we can do is say, how does my mouse behave? What CAD system am I coming from? So it makes it a little bit easier for me to use Onshape because the buttons move exactly the same. I can zoom in and zoom out exactly the same. There's also, stolen from SOLIDWORKS, this ability to have a little pop-up menu with frequently used commands. You obviously define those. So if I'm in a sketcher, it uses those commands. If I'm in assembly mode, it uses those. This is all customizable, but you kind of get the gist of that. So let's go back and take a look at Onshape. I'm going to talk a little bit. One of the things that we can do here is I could say, let's search. If I want to search for something, because it's kind of data management built in, I can search for the type of part it is. Is it a part? Is it an assembly? Is it a drawing? And then I can say, search by part number. What state is it in? Is it pending? Is it released? Is it obsolete? Is it rejected? Things like that. And then I can also use other types of criteria, user-defined parameters to search on as well. So these are all kind of searching capabilities that you usually see in the searching of PDM system, something like that. But let's go and take a look at an example here. One of the things, when you've probably learned maybe a couple CAD systems in your life, but they're all, I don't want to offend anybody, but they're all kind of the same. And really the question is, where are the buttons to do what I want to do? And another thing is, and once you figure that out, you're good to go. But another thing is nomenclature, the words that they use to describe things. So you'll heard me using the words mates, and SOLIDWORKS uses the same concept of mate, but they're a little bit different. I'm going to show you that right now. Also, what I have is what we call like a workspace, but it has part studios in it. So in a part studio, this is where we create geometry. So we have all the features for creating parametric geometry right here. So extrudes and lofts and draft and all those kinds of things. And then we have a little area here for non-parametric changes, right? So if we want to move a face, or we want to remove a face, or do different things like that, or we can come over here and we can say, create a selection. And then what do we want to search for? I mentioned before that we can search by kind of feature recognition, so holes and fillets and things like that. So a lot of different ways of grabbing geometry that was imported and being able to work with it. So what I wanted to do is talk about this part studio. This is where we create geometry. So I have actually 2 part studios in this workspace. Here I have another one. So I'm making, this is like a real simple clamp, but these are just created geometry. It technically isn't an assembly yet. Even though I modeled these parts to fit together, it's really technically not an assembly. What I can do is I'm going to say, let's go in here and create an assembly. So this is where I could create a drawing. I can create another folder and put some other documents in here, maybe part specifications or customer requirements, or maybe some images or whatever I need to kind of help me develop this product a little bit better. So this workspace and these part studios can hold lots of information relevant to the product that you're designing. But what we're going to say, and I can also import, right? So this is where I can say, let's import our SOLIDWORKS. But I'm going to say, let's create an assembly. So it brings up an empty assembly. And now I can start inserting geometry. So the first thing it says is, what do you want to insert? And I'm going to say, well, let's insert this first part studio we were looking at. So it brings that in. So we have it sitting here. And I'll say, let's just put it at 0, 0, 0. So I have 3 parts here. I can grab a part and kind of drag it out. They're not tied to one another. They just happen to be in the same place because I designed them that way in the part studio. So now I want to think about, in assembly mode, you notice the menus have changed. This is where I start to put things together in kind of an intelligent manner. Now, if they're never going to move relative to one another, I can just grab all of them and say, fix them. Don't let them move relative to one another. And it would do that. But in this particular example, there are parts that are going to move around. So the first thing that I typically do is I'd grab on one part and I'd say, let's fix him so he doesn't move. So if I grab him and try to move him, he doesn't go. But still, the other parts can. Right? So then the next thing I'm going to say is, I'm going to grab both these guys. And it could be, I could grab, box select like 100 parts. And I'm going to say, let's group those guys together. So here's like a group mate. And so what it does is it locks them all together. The thing is, since he's fixed and he's locked to him, now they're both essentially fixed. So you don't have to go around and fix each part. But this guy's still free, right? Still free to move around. And that's good because in this particular assembly, this does need to move around. So this is where we're going to start to use the Onshape mates. So there's different ones, right? We can create a mate somewhere, and we'll see what those are in a second. But we can create one where basically they're mated together, they're fixed together, and we can have revolves, and we can have sliders and cylindrical joints and ball joints and all those kinds of things. So if I wanted to put these two together, it would really be kind of a slider joint. So here's a slider. And I come over and I look at this, and Onshape's going to sample the geometry. And you know, if I pick up here, it says, well, if you pick on an arc, it can put a mate. So these are mates. And if you look at them, you notice how there's three different arrows there, and they represent X, Y, Z. It's just a little baby coordinate system. And so what I'm going to say is, let's put a mate right in the middle, right there. And then we'll go over on this face, and we'll say, pick one right in the middle of this guy. So two mates have put these two parts together. And if I go back, kind of look at it, let's kind of move it back a little bit. If I grab this guy, and now he can slide off, slide on. He's ready to go, right? Just one single mate. 99% of the time, you'll only need to put in one mate to put parts together. So let's go and bring in the other stuff. So I'm going to say, let's insert our second group. I'll bring him in, and we'll place him maybe right there. And so in these particular parts, I'm going to say, I'm going to fix all these. I could put a ball joint on here, but I'm kind of running out of time a little bit. So we'll bring him in, and I'm just going to grab these guys. I'm going to say group them together. So I'm locking all of them together. So now if I grab this and drag it around, all three go together. So you can see it's really easy for us to start grouping, logical things that don't move relative to one another together. So I want to put him in here, and I'm going to say, in this case, let's go and put in, let's put in a cylindrical joint. And we could say maybe from right here to this hole, maybe right there. So now we have a cylindrical joint. Now, as a cylinder, we can move this guy infinitely out or infinitely back. So what we can do is put limits on this. And what do we want the limits to be? I could say the minimum is right where it is, or we could say we can move it maybe 3 inches. And then the max is 0, kind of where it is. So now if I grab this guy and I drag him out, he goes, that's where 0 is, and then that's where 3 is. So if I go and grab this guy and start to drag him around, now we can have a functioning. And how many mates did I use, right? I used one here and then one there. And then the rest were just dragging a box around and kind of doing a group mate. And the mates are listed right here, right? So in the model tree, when we're working in the part studio, we have features here. In the assembly, we have the different parts that are added. And then we also have the mates, or the things that put them together and how they're held together. At this point, if we look at the history, our history tree is really small, right? Because we just kind of started this out. I can kind of expand it out, but this is the things that we've done. So I mentioned before, it saves everything. This is every single command I've done, and this will always be here. I can save a particular moment in time. I can make this a version. So I'll say, let's just call it, I don't know, like a fully assembled. So now we've made a moment in time called fully assembled. And I can always go back to this particular point. I can go back to any of these other guys that we saw here in the history as well. But this is something at this particular point we could say is, this is an important point that we want to know or that we want to work with. And also, I could just come to this assembly and say that I want to go and release this. Now that it's all put together, it's ready to go, I can say I want to release. This is all data management stuff. And here it is, it's going to be version A. I could make it version B if I wanted to. Here are all the parts. Here's the automatic part numbering system. We can customize this to number them the way that we want. But here it puts in the names, part numbers for all of that. I would give it a released name. You notice it's highlighted in red. You have to do that in order to use it. And then we can put in a list of approvers. Because there's a workflow associated with this, it automatically goes to somebody to approve it. But we can put in some other people, or maybe some observers, right? The people we want to have know that this has happened and to kind of monitor that. So kind of the blurring of data management in CAD is here in Onshape. So let's close this guy out for a second. I wanted to highlight a couple other things kind of along the same lines as nomenclature before. So here's another example that I have. And this is going to talk about branching. I mentioned that before. It's unique. I've only seen it in one other CAD package, and that was an SDRC back in the old days. But these are two parts that are just sitting on top of each other. And my thing is I want to figure out what's the best way to fasten these two parts together. So I send it out to a bunch of guys, because remember, a bunch of us can work on this at the same time. But one guy is going to say, well, I want to do it this way. Another guy says, I want to do it that way. So this is where branching comes in. So again, looking at the history, all I do is I just go to this particular point in time, and I say, let's branch off. And I give one branch to one guy, another branch to another guy, and so on and so forth. And they all come up with their different ideas. This is kind of Onshape's way of doing a save as without all the files and the mess and the management and all that other junk you have to deal with. So first guy, we can take a look. We can just review his. He's saying, let's use a slot to put these together. So if I click on his idea, so that's this little branch right here, we can see he cut a slot in here, and they just kind of fit together that way. The next guy said, let's weld it together, just weld the two pieces together. So I can look at it this way, see a little chamfers in there so we can put in weld. Next guy said, well, let's add screws to this. So this is all the same part. It's just kind of variations of the part, different branches. And we can say, let's fasten them together with screws. And then finally, the last guy goes, well, let's just make a single part. Why do we have to fasten them together at all? Let's just make it kind of a casting. I didn't put any draft or rounds on it, but a single part idea. I can grab any of these that I want. I can say the screw idea is good, merge it back in, and now that becomes, going forward in our main history tree here, that just gets merged into there, and that's our current part that we go forward with. Really easy to do design reviews with this, right? Because they're all in the same database. So branching is tremendously powerful. Once you know that it's there, you can find lots of ways of doing it. I'm just doing it here for different ideas, but you can do it for lots of other things as well. Another thing I wanted to talk about is, let's do compare. So I mentioned before that we're going to be bringing in SOLIDWORKS data, and then we might make changes to it, right? Changes happen. So I wanted to show you something. Here's a part. So I'm going to go back in its history. I'm going to say, let's go way back to the very, very beginning. So even farther than this, right back to where I imported it. I'm going to say, let's look at that. So I imported it. It looked like that. And I'm going to do, let's do a compare. So we do a compare from where I imported it there to where it is now. So it's doing that compare. So the import features are going to be on the left, which we imported it so there aren't any features. And then as we started to add features, we have those. And what we can do is there's a little dragger bar here, and I can see the changes. So it's basically just running down this model tree, showing me the things that I did. So I split this thing in half. I pulled it apart. I kind of cocked this guy. If I look at this one, let me see. Let's transform. I cocked this thing off at about 15 degrees. Right? So you can see that I did that. If there were another feature on this side, it would compare them, right? And we'd see this one is at 15 degrees and the other one was at 0 or something, had I created it in Onshape. But here we just brought it in, so there has no history tree here. But we can see as I drag this around, we can see the whole history of this part. And this is what we finally ended up with. So really kind of cool how this works, how we can review parts and their history, not only from the very beginning, but at any point in time. As we saw, everything was stored. I can go back to any point and compare it. So, back in July, we sent it to this customer. What did it look like in July? All I do is go down the model tree and I can see that. And if you were smart, you'd obviously make a version and saying this is going to customer so-and-so. So it's easier to find it in the model tree by looking at the version. The last thing I want to talk about real quickly is configurations. That's another thing that, same word that SOLIDWORKS uses, that Onshape uses, but they're different. So for instance, a configuration in Onshape, there's 3 different kinds. So in this particular case, this is just kind of a electrical thing, right? So kind of makes a connection there. And this is typically how most people do configurations. It's just a big spreadsheet. So here are the different variations or different names, and then here are the different lengths that are associated with those. But Onshape does 3 different kinds, as I mentioned before. We can do a list, like most people do. We can do a checkbox, which is turn stuff on or turn them off, suppress or not suppress type of things. And then we can actually put in variables as well and use those variables to drive some of those things. So 3 different things that can be configured. So you can actually make a couple of little tables instead of making one giant, huge spreadsheet. Just a couple of little tables will do that, and you just make a couple of choices out of each one, and you get your design. There's also capability here where we can configure, what we have here is assembly properties. So for assemblies and parts, well, let's look at assembly properties. So they could have different part names, different descriptions, different titles, all of those types of things, which obviously are changeable. In a part, we could have different materials, different colors, all those kinds of things as well. So lots of different ways of configuring things. So in this particular guy, when we make a configuration, it shows up over here in the model tree. So we could say, let's make this like a short bar. And so when I do that, it goes and changes our design right here, and it gives us kind of the shortened version of this guy. Or, give us a medium bar, or, we'll go to the long bar. And then do we want this little connector on the end or not? So I could say no connector on the open end, right? So he goes away. And then I could also come over here. Again, it's using the checkbox type stuff. Do I want the hardware or not? And I could say no, and the hardware goes away. So lots of different things that we can do to kind of create these configurations. And you notice it's very small, very simple to get at. It kind of breaks it into chunks, and it works a lot better interacting with other chunks than making one great big huge one, because they can get unwieldy, as you probably know, depending on the type of products you make. So I went over my 30 minutes, but that kind of brings us to a close about Onshape.